Hello everyone, I'm Farad from ECEC section, and in today's video we're going to talk how to find the powers of a matrix by diagonalization method. Let's first see what is diagonalization. Matrix diagonalization is the process of taking a square matrix and converting it into a special type of matrix, a so-called diagonal matrix that shares the same fundamental properties of the underlying matrix. Matrix diagonalization is equivalent to transforming the underlying system of equations into a special set of coordinate axes in which the matrix takes this canonical form. The remarkable relationship between a diagonalized matrix, eigenvalues, and eigenvectors follows from the beautiful mathematical identity, the eigendecomposition, that a square matrix A can be decomposed into a very special form. A is equal to PDP whole inverse, where P is a matrix composed of the eigenvectors of A. D is the diagonal matrix constructed from the corresponding eigenvalues, and P inverse is the matrix inverse of P. According to the eigendecomposition theorem, an initial matrix equation Ax is equal to y can be written as PDP inverse of x is equal to y. How to find the power of a matrix? To find the power of a matrix, multiply the matrix by itself as many times as the exponent indicates. Let's take an example. How to determine the matrix with the power 4? A to the power 4 is equal to A into A into A into A. A is multiplied 4 times. Therefore, to calculate the power of matrix, you must first know how to multiply the matrices. Otherwise, we won't be able to calculate the power of a matrix. Let us take an example. Let A be 2 into 2 square matrix. The fourth power of the matrix A is calculated as follows. A is given as 1, minus 1, 1 and 0. A square is written as A into A, which is 1 minus 1, 1, 0 into again 1 minus 1, 1 and 0. And here is the output. And A cube is equal to, as we multiplied A square into A, which is 0 minus 1, 1 minus 1 into 1 minus 1, 1 and 0. And here is the output. A to the power 4 can be calculated as A cube into A, which is equal to minus 1, 0, 0, minus 1, 1, minus 1, 1 and 0 is equal to minus 1, 1, minus 1 and 0 is the output. What is the nth power of a matrix? The nth power of a matrix is an expression that allows us to calculate any power of a matrix easily. Many times, powers of matrices follow a pattern. Therefore, if we find the sequence that the powers of a matrix follow, we can calculate any power without having to do all the multiplications. The formula of some matrix power can be found as follows. The parity of the exponent, it may be that the even powers are one way and odd powers another way. Here is the example how we can calculate n powers. In first one, in the place of n, it is given 2. So a square is equal to a into a, which is 1 and 1, 1, 1 and 1 into 1, 1, 1, 1, which is equal to 2, 2, 2, 2. And here are some examples. When calculating up to a to the power 5, we see that the powers of matrix A follow a pattern. With each increase in the power, the result is multiplied by 2. Therefore, all the elements of the matrices are powers of 2. A square can be written as 2, 2, 2 and 2, which is equal to 2 to the power 1, 2 to the power 1, 2 to the power 1 and 2 to the power 1. A cube can be written as 2 square, 2 square, 2 square and 2 square. A to the power 4 can be written as 2 cube, 2 cube, 2 cube and 2 cube. A to the power 5 can be written as 2 to the power 4, 2 to the power 4, 2 to the power 4 and 2 to the power 4. So we can deduce by induction that the formula for the nth power of matrix A is as follows. A to the power n is equal to 2 to the power n minus 1, 2 to the power n minus 1, 2 to the power n minus 1, and 2 to the power n minus 1. And from this formula, we can calculate, for example, a matrix which is raised to 100 as A to the power 100 is equal to 2 to the power, in place of n, we have to substitute 100 minus 1, which is equal to 2 to the power 99. Let us see problem, which is by which we can diagonalize the matrix. Here in the following square matrix, which is order of 3, A is equal to 3, 4, minus 1, minus 2, minus 3, 1, minus 2, minus 3, 0. Let us calculate a higher value rather than 5 or 10. Let's calculate A to the power 62. As 62 is a calculation which is too large to do by hand, so the powers of matrix have to follow a pattern. In this case, let's multiply up to A to the power 6 in order to find out the sequence that they follow. Let's start with A square, then A cube, then A to the power 4, A to the power 5, and finally A to the power 6, which is equal to A to the power 5 into A. With these calculations, we can see that every 3 powers we obtain the identity matrix. In other words, powers A cube, A to the power 6, A to the power 9, A to the power 12, so on, result in the identity matrix. So to calculate A to the power 62, we have to decompose 62 into multiples of 3, which is equal to, 62 is equal to 3 into 20 plus 2. Thus, A to the power 62 is 20 times A to the power 3 and once A to the power 2. Since we know that A to the power 3 is the identity matrix, A to the power 3 is equal to I, which A to the power 62 is equal to A cube whole power 20 into A square is equal to I to the power 20 into A square. Besides, the identity matrix raised to any number gives the identity matrix. So, A to the power 62 is equal to I to the power 20 into A square is equal to I into A square. Finally, any matrix can be multiplied by the identity matrix, which results in the same matrix. So, A to the power 62 is equal to I into A square is equal to A square. So, A to the power 62 will be equal to A square. A to the power 62 is equal to A square, which we have already calculated in the starting. So the output is 3, 3, 1, minus 2, minus 2, minus 1, 0, 1, and minus 1. Let us see another problem. This is a complex problem. Let's see how to calculate. A is equal to 1, 1 by 5, 1 by 5, 0, 1, 0, 0, 0, 1. Let's calculate A to the power 100. As again, A to the power 100 is the power which is too large to calculate by hand, which means we can calculate it using A to the power 5 to find out the sequence. Let us calculate till A to the power 5, which is equal to A to the power 4 into A. Thus, at each power, all the numbers remain the same except for fractions, which increases by 1 unit in the denominator. As you can see here in A square, it becomes 1, 2 by 5 and 2 by 5. In A cube, it becomes 3 by 5 and 3 by 5. A to the power 4, 4 by 5 and 4 by 5. At A to the power 5, it becomes 5 by 5 and 5 by 5. So the formula that defines the nth power of a matrix in this problem is A to the power n is equal to 1, n by 5, n by 5, 0, 1, 0, 0, 0, 1. And from this formula, we can find A to the power 100. A to the power 100 is equal to 1. In the place of n, we have to substitute 100. 100 by 5, 100 by 5, 0, 1, 0, 0, 0, 1. 1, the output is 1, 20, 20, as 100 by 5 is 20, 0, 1, 0, 0, 0, 1. We can easily calculate the nth power of a matrix using these formulas. Thank you.